Hello students, today we're going to discuss a new chapter, that is relations and functions. Okay, so before we start this, just make sure that you have knowledge on the chapter sets. Okay, if you don't, then go watch my last videos. I have already made 9 videos on that chapter. Okay, and that chapter is completely done. So I will provide the links of my last videos in my description box of this video. Okay, so now you see in this video we're going to cover only these two Cartesian products of two sets and relations and functions. Okay, so we cannot cover all the topics in the same video. Okay, because it is a very long chapter. So here you see in the relation and function we're going to learn how to find domain, range, codomain, different types of relations like reflexive relation, symmetric relation, transitive relation, equivalence relation, and inverse relation. Then after completing those topics, in the next video I'm going to show you how to solve the problems of NCERT textbooks, okay, related to relations. Okay, then we're going to discuss about functions. Okay, and here some important definitions related to functions, then various types of functions, their graphs. Okay, then again I'm going to make another videos to solve the problems, NCERT problems related to functions. Okay, so let's start. So now let us discuss about Cartesian product. So the Cartesian product of two non-empty sets, suppose a and B are two non-empty sets, then the set of all ordered pairs x comma y, where x belongs to A and y belongs to B. Okay, or in set builder form you can write A cross B, that means product of set A and B. Cartesian product of set A and B is the set of all ordered pair, that is x comma y. It is called ordered pair such that x belongs to A. Okay, that means x is an element of set A, y is an element of set B. So let me give you an example. Okay, suppose set A contains 1 comma 2 and set B contains suppose 2 comma 3. Okay, then what will be the Cartesian product? A cross B. Okay, it's very simple. So how to obtain the ordered pairs? Just here you see 1 comma 2 will be one ordered pair, 1 comma 2, and then again 1 comma 3 will be another ordered pair, 1 comma 3. Okay, then 2 comma 2, then again 2 comma 3. Okay, 2 comma 3, this is another ordered pair. Okay, so here you see these are called ordered pairs. Okay, these are called ordered pairs, and here you see each ordered pair contains two components. This one is called first component and this one is called second component. Okay, so here you see this one, you can take this one x comma y, ordered pair x comma y. So here x is the first component and y is the second component. Okay, so here 1 is the first component, 2 is the second. 1 is the first, 3 is the second component. 2 is the first component, here second component is also 2. Okay, so hope you have understood what is Cartesian product and how to find a Cartesian product. Okay, let me show you one more example. Suppose another set P, suppose it contains A, B, and another set Q, suppose it contains C, D, and E. Okay, so then P cross Q will be given by A comma C, first order pair A comma C, then again A comma D, A comma D. Okay, then third order pair will be A comma E, A comma E. So now let's start with the second element of P, then B with C, then B comma C, then B with D, that is P comma D. Next B with E, that is B comma E. Okay, so that's how we can find a Cartesian product. And most importantly, remember one thing, that A cross B is not equal to B cross A. Okay, if A is not equal to B, okay, if A and B are two different sets and they are not equal, okay, then A cross B and B cross A cannot be equal. Okay, it is possible A cross B equal to B cross A. It is possible if and only if A is equal to B. Okay, so remember these things. Okay, so now contains n number of elements, and set B contains m elements, then number of elements in A cross B, that means Cartesian product of these two sets, will contain m into n elements. Okay, and the power set of A cross B, that means Cartesian product of A and B, will contain 2 to the power m into n elements. Okay, so let me take an example in order to explain this. Suppose let set A be a set containing 1 and 2, suppose elements 1 and 2, and B contains suppose 3 and 4. Okay, so here see, A contains 2 elements and B contains also 2 elements. Number of elements in set A is equal to 2 and number of elements in set B is also 2. Then according to this concept, here you see, if A contains n elements, B contains m elements, then A cross B must contain m into n. That's why then number of elements in A cross B must be 2 into 2, that's equal to 4, because number of elements in set A and number of elements in set B 2 each. Okay, so that's why number of elements in A cross B must be 2 into 2, that's equal to 4. Okay, so let me show you with an example here. You see, so as we have taken here A and B, these two sets, let's find the A cross B here. A cross B will be A comma 3, there will be one ordered pair, ordered pair is 1 comma 3 here, another ordered pair 1 comma 4, then next ordered pair is 2 comma 3, then next one 2 comma 4, this is another ordered pair. So here you see, we have to consider here one ordered pair as one element. So 1 2 3 4, we have got 4 elements. So you have understood this. Okay, so as we have got here also 4. So now you see, the power set of A cross B will contain 2 to the power m into n elements. Okay, if number of elements in A is n, number of elements in set B is m, then power set of A cross B must contain 2 to the power m into n elements. Okay, then according to that concept, if set A is this one 1 comma 2, if set A contains 2 elements, this is 1 comma 2 and this is the set B, then number of elements in power set of A cross B, okay, power set of A cross B, it must contain 2 to the power 2 into 2, that's equal to 2 to the power 4, which is equal to 16 elements. Okay, so power set of A cross B must contain 16 elements according to this concept. Okay, so let's find the power set of A cross B now. Let's find power set of A cross B. Okay, you know how to find a power set, I hope so. First we have to take a set of single elements from A cross B. Okay, 1 comma 3, here one ordered pair is one element, so it is a set of containing one ordered pair. So here 1 comma 4, this is another set containing second ordered pair, so this is third ordered pair here in this set, and the set containing fourth ordered pair. So first we have to take single ordered pairs in a set. Then we have to take double. Okay, so first let us take first and second ordered pairs in this set, 1 comma 3, 1 comma 3 and 1 comma 4. Then let us take first and the third ordered pair, 1 comma 3 and 2 comma 3. Okay, then let us take first and last ordered pair, 1 comma 3 and 2 comma 4. Okay, then let us take second and the third ordered pair, 1 comma 4 and 2 comma 3. Okay, then let us take second and last ordered pair, that is 1 comma 4 and 2 comma 4. Okay, 2 comma 4. So here, this should not be written here, 2 comma 4. Then let us take third and last ordered pairs in the next set, 2 comma 3 and 2 comma 4. Okay, then we have to take subsets. These are all nothing but subsets of this set A across B. Okay, so we will take subset containing 3 elements. That means 3 ordered pairs would be there. Let us take first, second, third in the first subset here, 1 comma 3, then 1 comma 4, then 2 comma 3. Okay, then let us take first, second and fourth. Okay, in the next set let us take first, second and fourth, that is 1 comma 3, 2 comma 3, then 2 comma 4. Okay, then let us take first, third and fourth. Okay, so 1 comma 3, 2 comma 3 and 2 comma 4. Okay, then we will take second, third and fourth ordered pairs, so 1 comma 4, then 2 comma 3 and then 2 comma 4. Okay, so these are all possible subsets containing 3 elements. Let us find a possible subset containing 4 elements. There will be only one. Okay, containing 4 elements, that means 4 ordered pairs. So that's here. Let us write all the ordered pairs, because A cross B contains only 4 ordered pairs here, 1 comma 4, 2 comma 3 here, then 2 comma 4. Okay, so then, and we know phi is the subset of all sets, so there should be phi. So here you see, according to our calculation, it should contain 16 elements. Okay, this A cross B must contain 16 elements. So let us count, does it contain 16 or not. So this is 1, 2, 3, 4, then here it is 5, this is 6, 7, 8, 9, 10, 11, so here 12, and this is 13, this is 14, and this is 15, and including phi there is 16. So here you see it is confirmed that it contains 16 elements. So hope you have understood up to this point. Okay, now let me tell you about relation. So what is relation? Okay, a relation is nothing but you see, set of ordered pairs. Okay, a relation is a set of ordered pairs. Set of ordered pairs. Okay, let me explain. So suppose we have a relation R from set A to set B, such that R, here you see, if R is a relation from set A to B, must be the set of ordered pairs x comma y, where x belongs to A and y belongs to set B. Okay, so suppose here you see, and remember one thing, that R is either subset of A cross B and equal to A cross B. Okay, either subset of A cross B or equal to A cross B. Okay, so let me give you an example here. Okay, let me give you an example. Suppose we have two sets. One is A, another is set B. Okay, and set A contains elements, suppose 1, 2 and 3, and set B contains 2, 3 and 4. Okay, and 4. Here you see, suppose we have a relation between these two, that is, suppose R, such that R is a relation containing x comma y, where x is less than y, where x belongs to A and y belongs to B. Okay, so now you see, I have already told you that relation must be the subset of A cross B or maybe equal to A cross B in some point. Okay, so now let's find the A cross B. Now let me show you how to find you know already how to find A cross B. A cross B. So here you see, I have told you that set A contains 1 comma 2 comma 3, and here you see B contains 2 comma 3 comma 4. If you find a cross B or Cartesian product of these two sets, then you will get 1 comma 2, 1 comma 2, then 1 comma 3, then you will get 2 comma 2. Sorry, before going to that, let me write 1 comma 4, then again 2 comma 2, then you will get 2 comma 3, then 2 comma 4, then you will get again 3 comma 2, next you will get 3 comma 3, then you will get 3 comma 4. Okay, 3 comma 4. So here you see, so what is the relation here? So relation is a set of the ordered pairs, only those ordered pairs where x is less than y. This is the relation, x is less than y. So x is the first component, x is the first component here, x is 1 and y is 2. Okay, so now you see, then if x is less than y, then which are the ordered pairs that can be included in the set of R? Okay, so where the first component is less than the second component, only those ordered pair can be taken in this relation according to the definition of this relation. This relation R here says that x is less than y. Okay, so here you see, in the first ordered pair, first component is less than second, so we can take 1 comma 2 here. Then in the second also, first component is less than second, in the third as well. Then in the fourth ordered pair, here you see both the component, first and second components are equal, so we cannot take this one. So we can take the second and third ordered pair here, 1 comma 4. Then in the next ordered pair, 2 is less than 3, so here you see it satisfies the condition given here in the relation R, so we can take this one as well, 2 comma 3. Then 2 comma 4, we can take 2 comma 4. Then you see we cannot take 3 comma 2 because here the first component is greater than the second, it is not less than the second, so we cannot take. Then 3 comma 3 also cannot be taken, and 3 comma 4 also 3 comma 4 can be taken here. Let me erase this one, 3 comma 4. Okay, 3 comma 4. because 3 is less than 4. So we can take in this relation. Okay, now you see, so all the ordered pairs in the relation R belongs to A cross B, belong to the set A cross B. That's why R is a subset of A cross B in this case. Okay, so this is nothing but it is a relation. What is a relation in our mathematics? So it is nothing but set of ordered pairs. Okay, set of ordered pairs. Okay, which must satisfy the condition given in the relation. Okay, so if it is only given that R is a set of ordered pairs x comma y such that x belongs to A, y belongs to B, then we can take all the ordered pairs in A cross B. Okay, so in that case R will be equal to A cross B. But here we have a condition, we have got a condition here that x is less than y. So this is a relation such that x is less than y. Okay, so that means the first component must be less than the second component. So that's why we have to take only those ordered pairs here which satisfy this condition. Okay, so hope you have understood up to this. Now let me tell you about domain, range and codomain. Okay, what is domain? What is domain? Okay, so domain is nothing but the set of the first components of ordered pairs of the relation R. Set of the first components. Okay, first components of the ordered pairs in R. Okay, so this is the relation R. Okay, this is the relation R. So here you see all the first components here included in the set domain. Okay, so domain of R in this case for the above set. So here it will contain 1, 2 and 3. Okay, so here is the domain. Okay, and here you see, and the set of the second components, this is called range. Range is nothing but set of the second components of the ordered pairs of a relation. Okay, set of all the second components of the ordered pairs in the relation R. Okay, in the relation R. So that means in this case what are the second components here? So here we will get the range R is equal to range of R will contain here second components are 2, 3, 4. Here also 3 and 4 only, so we can take 2, 3, 4. Okay, and this set B is called codomain. Okay, codomain. So in this case, the example I had taken here, in this case, so I have got the range and the codomain same, but it is not necessary that always you will get the range and codomain same. Okay, in some cases you may get different codomain and range. Okay, so let me give you another. Suppose we have a relation from set A to set B such that R is a subset set of ordered pairs x comma y such that x belongs to A and y belongs to B, where x plus y is less than 4, less than equal to 4. Suppose less than equal to 4. Okay, x plus y is less than equal to 4. So we have a relation from A to B such that x plus y is, so here is the relation x plus y should be less than equal to 4. So in this case, here you see 1 plus 2 is less than 4. Then 1 plus 3 is equal to 4. We can take that one also. We can take 2 plus 2 is equal to 4. We can take that one also because it satisfies this condition x plus y less than equal to 4. But we cannot take 3 comma 4 and 3 comma 3 or 3 comma 2 either, because they are greater than 5. Okay, so now you see this set R contain, then it will contain 1 comma 2. Okay, 1 comma 2, then it will contain 1 comma 3. Okay, 1 comma 3, then it will contain 2 comma 2, 2 comma 2, then only these 3 ordered pairs will be included in this. Okay, which satisfy that x plus y is less than equal to 4. Okay, now here you see domain of R will be the set of first components here. So what are the first components here? Only 1 and 2. Okay, so this is 1 comma 2, and the range, in this case range will be the set of second components. What are the second components? 2 and 3 here. This is second 2, so 2 comma 3. Okay, and this set B is called the codomain. Okay, codomain. So hope you have understood what is the domain, range and codomain. Okay, so and remember one thing, a relation from one set A to another set B, instead of from one set to another set, we can establish a relation on a single set as well. Okay, a relation R can be on a single set as well, single set A. Okay, in that case R will be subset or equal to A cross A. Okay, so remember that. Now let me tell you about reflexive relation. Okay, what is reflexive relation? Okay, so a relation R on a set A is said to be reflexive if x comma x belongs to R. Okay, or it also can be written as x R x. Okay, for all, this symbol represents for all. Okay, for all x belongs to A. So let me explain it. Suppose we have a relation on set A. Suppose set A is 1 comma 2 comma 3. So this is a set containing 1 comma 2 comma 3, these 3 elements. Then a relation R, such relation that it contains ordered pair 1 comma 1, 1 comma 2, then 2 comma 2, then 3 comma 3. Okay, it's such a relation. It may be any relation that I have taken here containing. Now here you see it contains what are the elements in set A? 1, 2 and 3. So it contains 1 comma 1 and 2 comma 2 and 3 comma 3. That's why this relation can be considered as reflexive relation. Okay, that is what reflexive relation. Now let me tell you about symmetric relation. Okay, what is symmetric relation? A relation R on set A is said to be symmetric if suppose x comma y belongs to R, it implies y comma x belongs to R for all x comma y, x and y belongs to set A. Okay, that means if R contains, if set R contains, if the relation R contains x comma y, then it must contain y comma x to be symmetric. Let me take the example. As a relation R on the same set, suppose A. Okay, on the same set we have taken a relation R. If it contains, suppose it contains 1 comma 2, okay, suppose 1 comma 3, and it contains 2 comma 3 and 2 comma 1, 3 comma 1, 3 comma 2. Okay, then here you see this is a symmetric relation, because here you see 1 comma 2 belongs to R and 2 comma 1 also belongs to R. Okay, 2 comma 1 also belongs to R. So similarly 1 comma 3 belongs to R, 3 comma 1 also belongs to R, then 2 comma 1 belongs to R, 1 comma 2 belongs to R, 1 comma 3 belongs to R, 3 comma 1 belongs to R, 2 comma 3, then 3 comma 2 belongs to R. That's why R is a symmetric relation. Now let me tell you about antisymmetric relation. Antisymmetric relation. Okay, so what is antisymmetric relation? Okay, a relation R on set A is said to be antisymmetric when x belongs to y, x comma y belongs to R, implies y comma x belongs to R. It is possible if and only if x is equal to y. Now you see, antisymmetric relation doesn't satisfy this condition when x is not equal to y. Okay, so this condition is satisfied by the antisymmetric relation only in case of x equal to y. So hope you have understood what is the difference between symmetric and antisymmetric relation. Now let me tell you about transitive relation. Okay, a relation R on a set A is said to be transitive if an ordered pair, suppose x comma y, belongs to R and y comma z belongs to R, implies x comma z belongs to R for all x, y and z belongs to set A. Okay, suppose let me take an example of transitive relation. Here you see this is a relation R on set A. Suppose it is, so it contains 1 comma 2, suppose 1 comma 3, then again 1 comma 4, then 2 comma 3. Okay, then here it contains 2 comma 4, so 3 comma 4. Okay, so this is an example of transitive relation. Now you see, if you compare with this definition, then here you see it contains 1 comma 2. Okay, 1 comma 2, and it also contains 2 comma 3, 2 comma 3. Okay, so according to this definition, to be transitive it must contain 1 comma 3. Okay, now if you check the elements here, you can see 1 comma 3 1 comma 3 belongs to R. Again it contains 1 comma 2 and 1 comma 4. okay, 1 comma 2 and 1 comma 4, and it also contains 2 comma 4. Okay, so here you see 1 comma 2, 2 comma 4, again it also contains 1 comma 4. So this is also a condition to be transitive. Okay, so similarly here you see in this relation we have 2 comma 3 and 2 comma 4, then also have 3 comma 4. So that's why it is a transitive. Now what is equivalence relation? So what do you mean by equivalent relation? A relation R on a set A is said to be equivalence relation if it is reflexive, symmetric, also transitive. Okay, also transitive. Okay, that means a relation R on a set A to be equivalence relation, it must satisfy the conditions to be reflexive, to be symmetric and transitive. Okay, only in that case it is considered to be equivalence relation. Okay, so now let me give you an example here. Okay, suppose R be a relation on set A which contains 1 comma 2 comma 3. Okay, and this relation is the set of containing 1 comma 1, 2 comma 2, sorry, let me write here, 2 comma 2, 3 comma 3 and 1 comma 2 and 2 comma 1. So what are the elements in A? 1, 2, 3, and this relation contains 1 comma 1, 2 comma 2 and 3 comma 3. That's why it is reflexive. So we know the condition to be reflexive. This a relation R is said to be reflexive if x comma x belongs to R, for all x belongs to A, isn't it? That was the condition. Here we have got 1 comma 1, 2 comma 2, 3 comma 3 for all the elements in set A. Okay, then let me check, is this symmetric or not? So what was the condition to be symmetric? If it contains x comma y, if the relation contains x comma y, that means x comma y belongs to R, then y comma x must be in the set R, then this relation R is said to be symmetric. Here you see we have 1 comma 1, 1 comma 2 and also have 2 comma 1 here, so that's why it is symmetric. So 1 comma 1, if you change the order, then again you will get 1 comma 1, and if you take 2 comma 2, if you change the order, then also you will get 2 comma 2. That's why you can consider this as symmetric. Okay, now let me check, is this transitive or not? Okay, so here you see we have 1 comma 1 here and this is 1 comma 2. Okay, then here you see, so again we have 1 comma 1. Now let me consider here 1 comma 1 belongs to R, then 1 comma 2 belongs to R. So if you consider this one as this is x, this is y, and this one is y and this is z, then according to the condition to be satisfied by transitive or you can say by the definition of transitive relation, if x comma y belongs to R, y comma z belongs to R, then x comma z must belong to R. Okay, so here x is 1, z is 2, then again 1 comma 2 belongs to R, so which is already there. Okay, so here we have considered one, this first one is x and second one as y, and here first one as y, then next component 2 as z. Okay, then you see 1 comma 2 belongs to R, that's why it is transitive. So it is transitive. Okay, let me write this properly. So here you see, again if you have 1 comma 2, 2 comma 1, again you have 1 comma 1 as well. Okay, so that's how you can say it is transitive. Hope you have understood. So as this relation R satisfied all these three conditions of reflexive, symmetric, transitive, that's why it is an equivalence relation. So hope you have understood. Now let us discuss about inverse. So what is inverse relation? Suppose we have a relation R from A to B, from A to B, okay, such that R is a set of x comma y such that x belongs to A and y belongs to B. Okay, then inverse relation of R inverse relation of R written as R inverse is given by y comma x such that x belongs to A and y belongs to B. So let me give you an example. Suppose we have a relation. If R is a relation, suppose this contains 1 comma 2 and 2 comma 3. Okay, then inverse of this relation, that is R inverse, is given by 2 comma 1 and 3 comma 2. Just we have to reverse the order of the components of the ordered pair. So that's how we can obtain inverse relation of a given relation. Okay, so hope you have understood this. So in the next video we are going to solve the problems of NCERT textbook of mathematics class 11 exercise 2.1. okay.